Here's my NES emulator for Xbox. We're going to do a little bit of more ROM hacking today. And today we're going to do Legend of Zelda for NES. I want to explain in this segment something called save states. Save states are commonly found in emulators nowadays, where basically it saves a specific instant in time. Meaning, you can actually roll back time. And it works by saving all of the memory addresses and all the things your CPU is doing. So we'll go ahead and do a save state. And then, oh, gotta run away. Oh no, went the wrong way. Load state. And it'll always load that exact instant in time. So it's really good if you're getting your ass whipped at a certain point of the game, or if you want to go and hunt for memory addresses. Alright, so we're going to go ahead and save. And I'm going to see if I can get the memory address for the sword. Alright, so we'll do some preliminary, start search. Now the value has most likely increased, so continue to search for greater than before. Okay, down to 76. Now we'll load state. Now that should have changed, so it should be less than before, because remember, we loaded before we had the sword, and the emulator itself is looking for changes. So it has changed. We forced it to change. So we're down to 35. We'll go in here again. I love that fast forward button. Okay, cheat codes, greater than before, 29. Load state, less than before. Okay, it's not going down fast enough, so we'll use a few different tactics. Okay, we'll do greater than. See, it's not going down fast enough, so what we'll do is we'll go around, change some of the graphics for the data, or the data for the graphics, whatever. So now it should be equal to before. Down to, what is that, 6? Yeah, we're down to 6. So we're going to go for broke. Add these to the list. So we're going to go to our cheat codes. Okay. We got 06D, 6E, 83, 618, 657, 6F6. I don't know. Well, actually, the only thing that looks like it's plausible is this 657 as a value of 1. Because if a value of 1 says we have the sword, a value of 0 means we don't have a sword. Okay, so it's value of 7, locked at this value, and goodbye sword. We have no sword. Huzzah, look at that. Alright, so we're going to go and edit this back to 1 to prove that this is, in fact, the address for the sword, and there's our sword. Okay, now let's see what these other ones do. Well, let's see. If 657 is the sword, a lot of games are actually sequential in their memory addresses. So it's safe to say that maybe 618 and 6F6 are also values of some sort. For maybe I do something useful. Alright, so let's take this up to FF, see if the game crashes or not. Enable this? Nope, I don't notice a difference. Alright. So we'll go ahead and delete this one. And we'll enable that to on. We'll edit this, so instead of 28, we'll make it 30, because this could be our lives. You never know what this could be. Nope. No noticeable difference. Alright, so we'll go ahead and delete that one. And I'm going to go ahead and just delete the rest of these. Okay, so we know that address 657 is for the sword. Now, what is at 658? Like I said, a lot of the times the addresses are actually sequential. So let's see, what was that address? 657? So let's see, it's 658. Am I in the right position? 658 0001. All right. So address 658. Set it to a value of 1, lock it in place, go back to our game. Hey, look at that. We have bombs. So my assumption was right, that the game actually does use sequential addressing for all of your weapons. All right, so what happens if we set a value 659? Hey, look at that. We've got arrows now. Interesting. Interesting. what happens if we use this cheat code 65A, because that is the next value. Now we have the bow and arrow. Interesting. So it's safe to assume that you can go through a whole list of all of these addresses and find out what addresses go where. And we actually figured out that by using save states, we figured out sooner than later, because once you have the sword, you have the sword. There's no getting rid of it. Using the save states and the load state, we were able to force the game to load a previous instance in time where the memory values have actually indeed changed. So one more thing that I want to point out is some games actually use a higher value for different weapons. So the address is the same, but the value is different. Now, I've already done a bit of poking around and lobotomizing to Legend of Zelda. So I know in this game that the sword is, in fact, memory address 657. And I also know what happens when you set it to value 2. And now I'm showing you. Look at that. We now have the next level sword. And if you set it to... Oh, sorry, wrong button. If you set it to memory value 3, you'll actually get the Master Sword. There you go. Now you got the Master Sword. So, some of the memory addresses, like for your potions and for your boomerang, are actually, if you can't find, like example, there's a blue and a red ring. The blue and the red ring might actually indeed have the same memory address, just have a different value. Here we are back in front of my NES emulator for Xbox, and we're going to do a little bit of poking around in Mega Man 2, one of my all-time favorite games to play and to poke around. So, we're going to start a normal game. I'm going to zip through this. I'll paraphrase just in case this is the first time you're seeing any kind of NES hacking or lobotomizing, so I don't want to get into too much detail. I can use my handy-dandy fast-forward button to get through all of the long waits. The first thing we're going to do is our health. We're going to go to our emulator, and we're going to start a search for what they would consider cheat code. Basically, we're using the cheat code system in the simulator, and we're going to get hurt. Now, as you notice, the health went down, so we're going to search for values less than before. Got 100 values left, and we're going to get hurt again. Okay, so apparently it's less than before. We're down to 25. And got hurt again. Cheat codes. Less than before. We're down to 12. It's slow and painstaking, but we're slowly getting there. Less than before. So there's only 5 values that have been less than in the previous. And one more time, just for good measures. Less than before. We're down to 2. I don't want to push our luck, so we'll add these to the list. We have 2 values. 24B and 6C0. Now, 24B is at a very high value at 164, which is decimal 164, and 6C0 is at value 12. I'm putting my money on address 6C0 because it's very low, and so is our health. So we'll go back to the game, and notice, however, whenever I get hit, because the emulator is basically telling the memory address to lock this at decimal 12, no matter how much I get hit, my lives, or my energy is not going to go down. But you know what? Constantly getting hit is really getting on my nerves. So we're going to go ahead and delete this 24B because it doesn't do squat for us. And we're going to start search for a new cheat code, or a new memory address, per se. We're going to get hit. Now we got to be quick on the button. Continue, start search. Continue, less than before. Cheat codes, less than before. Cheat codes, less than before. What I'm trying to look for right now is the timer address for whenever you get hit. It makes you flash for a little while, making you invulnerable to attacks for a little bit amount of time. So we're going to go and add the 4 values. I don't want to push our luck to the list. So, you know what, let's enter a description. And this is health points, HP. Now let's see. It starts at 6C0, and there's nothing close into that range. Now, if you've watched the Legend of Zelda lobotomizing, hacking, whatever you want to call it, I explain that certain addresses in certain games are in sequential order. Now, I know this game very well. I'm not going to let too many secrets out. But 4B looks like it's kind of low in memory, but in fact it could actually be the address we're looking for. I mean, it's at 36. It's one of the lower values here. I mean, 34 for